Hello, my name is Beth Ebersole, and I'm going to talk about the SAS Mitigate Bias action. This lets you mitigate bias right in the SAS tools. It's built directly in to, for example, SAS Machine Learning. A few examples of bias types in AI are sampling bias, where you have an unrepresentative sample. Another example is highly influential data points. And finally, perpetuation of historical bias. These historical biases can be perpetuated through automatic algorithms. Fit statistics used to measure model performance in the SAS tools are going to be our Max Kolmogorov-Smirnov statistic, where higher is better, the multi-class log loss, where lower is better, and the true positive rate, where higher is better. These are fit statistics that are used to measure model performance. So one of the things that we're going to look at when measuring or assessing bias is whether or not among different groups the model's performance is equally good. So it may be very accurate for one group but not accurate for another group. So that is called performance bias. And we measure that by looking at fit statistics grouped by each level of the sensitive variable. So if we're looking at, for example, gender, we would have male and female. Performance bias parity is the difference between the variable level with the highest value and the variable value with the lowest value. So in our example that we're going to go through, we're going to have males and females, and the difference between the fit statistics will be evaluated in the performance bias chart. So we'll be able to see, does this model perform equally as well for males as it does for females? Prediction bias is another measure, and this is the average predicted values for every level, including the missing values of the sensitive variable. In our case, the sensitive variable is sex. The prediction bias parity is the difference between the level with the highest average prediction and the variable with the lowest average prediction. For example, likelihood of failing to pay a loan, for example, and we will look at our sensitive variable of sex. Finally, we have bias metrics. These are assessment statistics for each level of a sensitive variable, and the bias parity metrics compares the assessment metric between the levels. Now I'm going to show you how the software works. First, I'm going to demonstrate assessing bias using SAS Model Studio, which is a visual interface, and then I'm going to show you through coding how we can also mitigate the bias. Here we are in the Data tab for SAS Model Studio. We're looking at age of death as our target, and we're going to select sex as our sensitive variable, the variable we're going to assess for bias. So we'll check over here on the right, assess this variable for bias. Next, we'll move to our pipelines, and we have just our Data tab, so we'll add a gradient boosting, and run the pipeline. Now we see our pipeline has run. We can look at our gradient boosting results. Right-click Results. And you see we have three buttons: Node, Assessment, and we also have Fairness and Bias. I showed you this in a previous YouTube by using code, but now you see you can do this also easily with the visual interface of Model Studio. And we see we have our performance bias, our prediction bias. So here we're comparing how did the model do, the chosen model, which is gradient boosting. We only had one model. Now here we look at the prediction bias. This is, did it predict higher or lower levels for the females or the males? And we see the average prediction for the target variable was 71 for females and 70 for males, so fairly close. Now here we're looking at the performance bias parity. So we're looking at how different was the model performance for males and for females. And if we find that this difference is unacceptable, we may want to model these groups separately. And we have our prediction bias parity. This is looking at how were the results different for males versus females. And here we have our bias metrics. We have a whole host of metrics, and we have bias parity metrics showing us the base level being female and the comparison being male. Here we have the predicted age at death, the maximum metric difference, the mean absolute error, the maximum metric difference, root mean square error, average square error, etc. Now we did that using the SAS Model Studio visual interface, but we can also use the assess bias action via coding, as I showed in my previous YouTube. And now we're going to use coding to mitigate bias. Here I am in SAS Studio. I'm opening a CAS session and assigning a live name. And then I'm using proccacheUtil to load my data. I'm going to call it Heart1. And then I'm going to do some data manipulation. I'm only going to keep the data where cancer or coronary heart disease was the cause of death. And I'm going to rename coronary heart disease heart to make it easier to read. Finally, I'm going to do a proc print to make sure everything's running smoothly. I see everything worked fine, and I have this status. These are folks who have died. Obviously, if they haven't died, there's no death cause yet in the study, so we've selected only those who have died of coronary heart disease or cancer. Now I'm going to run my gradient boosting. And I see that ran fine. I've put in 5 inputs: systolic, diastolic, weight, height, and sex. I can see information about the gradient boosting, like the number of trees, the distribution, learning rate, etc. So now I'm going to run my mitigate bias. This is within my ProcCAS. In my FAIR AI tools, I have my mitigate bias action. And I'll run that. So you see my event here is heart. I've selected a learning rate. I have 2 predicted variables, predicted death cause heart or predicted death cause cancer. So this is a binary outcome, and I'm using the example for a binary target. I also I'm using a binary sensitive variable here, which is going to be sex. I'm using male or female in this data set. That's what's available. You can see I have my save state statement, and I put out the Heart GB A store, and then I use that A store to score, to get my scored results, and I have this will output my results. So you see now that it has finished. I can open up my results in a browser tab to see them better. And here are my results from the FAIR AI Tools Mitigate Bias. You can see my bias metric is demographic parity. My sensitive variable is sex, and my response is death cause with the event level of heart. Here I see my constraint history, and I see my proportion into the event level for the sensitive level, overall proportion into the event level, gamma max, gamma min, and overall misclassification rate. And I can see my proportions here. I see my weight history, and now I have my group metrics. So here I have my true positive rate in iteration 1 for my females is 0.622, and for males 0.851. And then I see my true positive rate as I go down here to iteration 3, it has gone up for females and down for males, but it actually is closer to being the same. And I can look at not only true positive rate, I can look at my false positive rate, and I can see obviously true positive rate, higher is better, false positive rate, lower is better. The area under the ROC curve, higher is better. We can see our misclassification rates, our multi-class log loss, where lower is better, our best Kolmogorov-Smirnov statistic along the ROC curve, and where higher is better, and we see our cumulative lift, where higher is better, our cumulative response, proportion into event level, and average prediction for events. So this is a lot of great information. And here we can see our demographic parity. And we can see that in our first iteration, we had quite a bit of difference between males and females as far as the accuracy, and the misclassification rate was 0.330. We can see that we got a much better parity with our third iteration, and our misclassification rate is a little higher, but not that bad. So in this case, we may want to go ahead and accept these new results. Of course, this is just one way to mitigate bias. Another way, sometimes it's best to evaluate groups separately. This is a situation we're looking at medical information. Are you going to tell someone to quit smoking or lower their cholesterol? Like if they're going to do one, which should they do, right? Are they going to change their eating habits and lower their cholesterol? Are they going to quit smoking? Sometimes you want to evaluate groups separately and then give more individualized medical advice to specific groups where that advice applies more specifically to them. In the SAS documentation, the FAIR AI Tools documentation includes examples in CASTLE, Lua, Python, and R. These examples let you assess bias for a nominal or interval target using data, step, or DS2 scoring, using pre-scored data and reference level, or with no response variable at all. And now you can mitigate bias. You can mitigate demographic parity for a binary target with a binary or nominal sensitive input. And you can mitigate equal opportunity for a binary target with a binary or nominal sensitive input. And remember, you should always, always, always explore your data with visual analytics before you even start this process. See my next YouTube to learn about how you can look at bias using visual analytics. I'm Beth Ebersole with SAS. Hope this was helpful.